Today we're going to talk about properties of exponents and how to simplify algebraic expressions using these properties. First, let's make sure we know what I mean by base. The base is the number being raised to the exponent. So in this case, x is my exponent. Alright, first the important property we're going to talk about is this first one right here. When notice they have the same base. When they have the same base and they're being multiplied, we're going to add our exponents. Now when they have the same base and they're being divided, you're simply going to subtract your exponents. Now here we have an exponent being raised to another exponent. See how there's a parentheses right there? That means, usually parentheses means multiplication. So you're just going to take both of those exponents and multiply them together. Now, when we have a fraction and an entire fraction being raised to an exponent, all you're going to do is distribute that exponent to the top and to the bottom. Now, if we have a negative exponent, we're going to make that exponent positive by bumping it down to the bottom. When you move it down to the bottom or the denominator, the exponent will now become positive. And this last one is basically just saying the opposite. If the negative exponent is in the denominator, you can make it positive by moving it up to the numerator. On your own, I want you to go ahead and try to write an example of each property. So for instance, for the first property, an example would be if I had z to the second times z to the ninth. By using the first property, it says you add your exponents, so you would get z to the 11th. So again, on your own, you can pause the video and go ahead and try to write an example of each property that we filled out. Alright, our first example, we want to try to simplify this expression as much as possible. So first, let's look at this 25 and 15. So first we want to reduce that fraction. Well, 25 and 15 both have a 5, so I can take a 5 out and I'll be left with 5 over 3. Now we want to take a look at the ones that have the same base. So in this case I'm looking at x to the negative 2 and x cubed. Now in this case they're being divided, so all you're going to do is you're going to subtract your exponents. So if I take, off to the side I'm going to do this, if I take negative 2 minus 3, so that turns into a plus negative, so I'm going to get negative 5. Well, if I have a negative exponent, I want to make the exponent positive, so I'm going to put it in the bottom in order for it to become positive. Now we move to our y's. So if I subtract, I get 8 minus 8, which gives me 0. So both the y's are going to cancel out. Then I go to my z's. I have z to the 11th over z to the 9th. So I subtract them. I get a positive 2 when I subtract. So that means I'm going to leave the z's on top. So 5z squared over 3x to the 5th would be your final answer. Alright, in this case, notice we have two separate expressions being raised to exponents. So the first thing we want to do is we want to go ahead and take this exponent and distribute it in to each term. So when we distribute it into each term, I'm going to get 4 to the negative 2, x to the negative 4 because we multiply our exponents, and then y to the negative 6. Times, and notice I dropped the parentheses, so I get 2 to the 6th, x to the 18th, y to the 12th, again because I'm multiplying my exponents. Now in this case, 4 to the negative 2 is really saying 1 over 4 squared, which 1 over 4 squared ends up being 1 over 16. If I do 2 to the 6, 2 to the 6 is going to be 64. So off to the side here, if I take 1 over 16 times 64, it's the same thing as saying 64 over 16, which will reduce down to 4. So I'm going to get 4. Now notice I have x to the negative 4, x to the 18th. So they're being multiplied, so I'm going to add my bases. So negative 4 plus 18 is going to give me 14. So I get x to the 14th. Then I have y to the negative 6, y to the 12th. I add my exponents, I get y to the 6. So my final answer is 4x to the 14th, y to the 6. Alright, this is the last example we're going to go through together. Similar to the last one, I'm going to take this exponent and distribute it into everything into the top, and then do the same thing for the bottom. So the first thing, let me go ahead and erase that first. So the first thing, I distribute it to the top. So I'm going to get 4 to the 4th, a to the 8th, b to the 4th. Again, you're multiplying your exponents. If I distribute it to the bottom, I'm going to get a to the 4th, b to the 12th. Times, I do the same thing on the second one. I distribute the 2, so I get a squared, 2 squared, b squared. Now in this case, 4 to the 4th, I'm going to go ahead and cross through that. 4 to the 4th is going to be 256. So I'm going to scratch that out, do 256. 2 squared is going to be 4. So I'm going to go ahead and combine the numerator. So I'm going to multiply straight across. So I'm working straight across right here. So on top, I'm going to get 256. I have a to the 8th and a to the 2nd, so I'll get a to the 10th. There's no more b's, so I get b to the 4th. Over, I do the same thing on bottom, so I'm going to have 4. There's no other a's, so I'm going to still have a to the 4th. If I combine both my b's right here, I'm going to get b to the 14th. So now we're going to go ahead and reduce. 256 divided by 4 is going to give us 64, and that's going to stay in the numerator. I subtract my exponents right here. 10 minus 4 is going to be 6, so I get a to the 6th. Now when I subtract my b values, you're going to get 4 minus 14 gives us negative 10, but to make it positive, I'm just going to write it down in the bottom. So I'm going to have b to the 10th in the bottom. So my final answer is 64 a to the 6th over b to the 10th. Now these are the most important properties of exponents. Realize we are going to go through more examples together in class.